I want to tell you when you want to construct network using the project evaluation and review technique. In construction of network using the PART method, there are 3 time estimates which are given. And these 3 time estimates will be used to calculate the expected time for each activity in the project. Eventually, we can calculate the variance for each activity using the time estimates. We can also calculate the standard deviation for each activity and also the standard deviation for the project. Then we will also know how to calculate the probability of project completion time. So the 3 time estimates which are comprising the part are optimistic time, most likely time, and the pessimistic time. These are the 3 time estimates which we are going to use here in project evaluation and review technique, which is also known as PART. Optimistic time. Let me start by defining optimistic time. Optimistic time is the time which is taken for the performance or completion of an activity if everything goes on well in that project. It is the shortest of the 3 time estimates. Now, when you talk about optimistic time being the shortest, that would mean that you are planning to complete that project. But the requirements of the project, you have put them in a place ready for the activities to be performed or to be done or to be completed. You see, some of the components which comprise, some of the components which you must put in place for you to complete the project within the shortest time possible. One, you have put the machines, and the machines are in their working conditions, you see, such that there will not be any stoppages. Maybe they have been maintained, you have conducted maintenance on them, such that they are readily in a place, they are ready to perform the tasks. Then the conditions of work you have also improved, such that the people who will be helping you to complete those activities are subjected to better working conditions and so on. That is what is known as optimistic time. Then the most likely time is based on chance or probability or likelihood. It is the time which is normally expected for the completion of an activity. It is the likelihood that activities will be performed as per the given schedule. But they might not take the duration which you had planned. They can take more or they can take less. Now that is most likely time. Pessimistic time is normally defined as the time which is taken for performance or completion of an activity. If everything goes on wrong in that project, you see, so it is the longest of the 3 time estimates. Now, these are the items or the estimates which we will be using. Now, for us to calculate the expected time for each activity, expected time for each activity, we use the PART formula. Expected time for each activity, we use the PART formula. expected time for each activity is equal to A plus 4M plus B divided by 6, where A is the optimistic time. Optimistic time for each activity. M is most likely time, and B is the pessimistic time. 4 is a constant, 6 is also a constant. We are going to see by getting an example and how to calculate those ones. Then we substitute those values of A, which will be given, M, then B to calculate the expected time for each activity. Then that is how to calculate the expected time. Then we can also use the formula to calculate the variance for each activity. Then variance for each activity is equal to B minus A over 6, the whole of that squared, where B is the pessimistic time for each activity and A is the optimistic time. 6 remains a constant, the constant. Now, we can also calculate the standard deviation. That is standard deviation for each activity. Standard deviation for each activity. Standard deviation for each activity is equal to B minus A all over 6 now. As you know, there is a link between variance and standard deviation. Standard deviation is the square root of the variance. And when you square the standard deviation, you get the variance. So this one is the square root of this, you get B minus A over 6. So that is on the part method. Now, I want to get an example, then do that example using the formula or the formulae which I've just given. We have now example 6. These are activities of a certain project whose duration, I think duration are in weeks. Duration are in weeks. So I think there is something to be altered here, kidogo. Duration in weeks. Now calculate the variance for each activity. Then second one, calculate the expected time for each activity. Then eventually draw the project network. Determine the critical path. Determine the critical path. And let us say, and the duration. Critical path. And we also want to know and the duration of of the project. So let me start by calculating the expected time for each activity. Sorry, by the variance for each activity. Activity A, we use the formula b minus a all over 6 squared. So that is b minus a all over 6 squared. So for A, B is the pessimistic time, which is 15 minus 3 all over 6 squared, which is 144 over 36. 144 divided by 36. That brings us 4 weeks. Then B, the variance for B is 14 minus 2 all over 6 squared, which is again 144 over 36, which is 4 weeks. Then C, the variance for C is 30 minus 6 all over 6, the whole of that squared, which is 20, this is 20 what? This is 24. 24, that is 24 divided by 6, that is 4. So 4 squared in a letter 16. So this one brings 16. This one brings 16 weeks. That is 14. That is 24. 24 plus that is 4. Divided by that. That is, yeah, exactly. Then D is 8 minus 2 all over 6 squared, which is 6, that is what? 1 week. You see D, then E. E is, the variance for E is 17 minus 5 all over 6 squared. That is 12. 12 divided by 6 is what? 2. That is 4 weeks. Then F. F is 15 minus 3. 15 minus 3 all over 6 squared. That is what? 12. That is what? 4 weeks. F, then G. G is pessimistic time is 27 minus 3 all over 6. The whole of that squared. 23 minus 3 is 4, 24. 24 divided by 6, that is what? 24 divided by 6 is 4. That is 16 weeks. Then We have G, then we have H. H, this is 7. 7 minus 1 divided by 6, the whole of that squared, which is what? 1. Then I. The variance for I is 8 minus 2 divided by that squared, which is what? 1. Those are the variances. Then, viewers, we must now calculate the expected time, which are also the durations. So, the expected time. So, the expected time, once more, expected time is given as A plus 4m plus B divided by 6. In fact, so that is the formula we are going to use to get the expected time. Expected time for A. Expected time for activity A is 3 plus 4 times 6, because it is 4 times, most likely time is 6, plus 15 divided by 6. Yeah, that is 3 plus 24. 3 plus 24 is 27. 27 plus 15 is 42. 42 divided by 6 is 7. Then B. B is 2 plus 4 times 5 is 20 plus 14 divided by 6. That is 20 plus 14 is 34. 34 plus 2 is 36. 36 divided by 6 is 6 weeks. Then A, B, C now. C. That is 6 plus 4 times 12, which is 48, plus 30 all over 6. So that is 6 plus 48 is 54. 54. This is 54. 54 plus 30 is 80. 84. So 84. That is 1. So that is 14. 14. 84 divided by 6. That is 14. So this is 14 weeks. Then D. That is 2 plus 20 plus 8 divided by 6. That is 22 plus 8 is 30. 30 divided by 6, that is 5 weeks. E. E is 5 plus 44 plus 17. Divide by 6. 49. 49. 49. This is 49. 49 plus 17. 49 plus 17. That is 66. 66 divided by 6 is 11 weeks. Yeah. Then E, F. 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 F is 3 plus 4 times 6, which is 24 plus 15. Divide by 6. So 24 plus 3 is 27. 27 plus 15 is 42. 42 divided by 6 is 7 weeks. Then we move to G. G is 3 plus 36, that is 4 times 9, plus 27. 3 plus 36 is 39. 39 plus 27. 39 plus 27 divide by 6. Divide by 6. This is 66 divided by 6, which is 11. Weeks. Then H. H is 1. 4 times 4 is 16 plus 7. Divide by 6. This is 17. 17 plus 7 is 24. 24 divided by 6 is what? That is 4. Weeks. I is 2 plus 4 times 5 is 20 plus 8. 22 plus 8 is 30. 30 divided by 6 is 5. These are the durations. These are the durations. These are the durations for each activity in the project. So, after calculating the variance and the expected time for each activity, I want to draw for you now, I want to show you how to draw the network using the durations which we have got. From there, I will estimate the duration of the project and the critical path. So let me record these ones. A is 7 weeks. B is 6 weeks. C is 14 weeks. D is 5 weeks. E is 11 weeks. F is 7 weeks. F is 7 weeks. And G is 11 weeks. G is 11 weeks. H is 4 weeks. H is 4 weeks. Then I is 5 weeks. I want to now draw the network after I've calculated the duration, the expected time for each activity. Activity A preceding activity or predecessor is dash. Activity B predecessor is also dash. So that is, this is the node now for the beginning. That is the starting time. There are two activities which occur earlier than any other activity, A and B. A and B are the first to occur. Then A and B are converging to give rise to C. When A and B are the first to occur, in fact, they are occurring simultaneously at the same time. And therefore, under normal circumstances, they cannot converge. That means those are dummy activities, and in a network, I'd said these ones are represented by dotted arrows. So there is a dotted arrow A and B converging here. A and B converging. They converge to give rise to C, to give rise again to D, to give rise to C and D. There are two activities which are coming from A and B, C, D, A, B, C, D. So A and B are converging to give rise to those two activities, and those two activities are, these are C and D. So we draw the node for the completion of that. So C and D are coming from the node which indicates that A and B are converging. So C and D. So B is giving rise to E. B is a preceding activity to activity E. And D and E are converging. So B is giving rise to activity E. Sorry, B is giving rise to activity E, which will converge with D. So that is, this is E. And we are told here D and E are converging to give rise to F. D and E are converging to give rise to F, and that F all goes all the way to meet with the C. There is CF here. So this is D and E to give rise to F. So C and F, they are giving rise to C and F. C and F, both of them give rise to G. C and F, G. So G is here. So you can now draw the node here. This is for G. Then C and F gives rise to the C and F, they give rise to G. Then D and E, so D and E gave rise to F. D and E again is giving rise, they are giving rise to H. So D and E to H. And H goes all the way to meet with G. So that is H. G and H they give rise to I, That is I. That is I. That is the project network. GH I. Because we are dealing with the construction of network using time estimates, we still subdivide each node into three parts to accommodate the event, earliest time, and the latest time. Then numbering of the events. 1, 2, 3, 4, 5, 6, 7. Then the expected time which we had calculated earlier are the ones now we transfer into the network to estimate the duration of the project and to determine the critical path. So A is 7, takes 7 weeks. B takes 6. C takes 14. D takes 5. E takes 11. F takes 7. G takes 11. H takes 4. And I takes 5. The project is starting here. That is the origin. It has not consumed time at this level, 0, 0. Then we start by estimating the earliest time. Earliest time, these are the upper parts. 0 plus 7, this is 7. Then this is 6. Obviously, even if you add this to 0, you'll get 6, and this is the maximum. Then 7 plus 5 is 12. 6 plus 11 is, the other one was 12. 7 plus 5 is 12. 6 plus 11 is 18. We take the maximum. Maximum is, 11 plus 6 is 17. Sorry, not 18. Sorry for that. 6 plus 11 is 17. And this is 12. This is 17, yes. Yeah, so that's okay. Then 7 plus 14 is 21. But when we approach it from this side, 17 plus 7 is 24. So the other one was 21, and this is 24. 24 is the maximum. So we are here now, faced by two parts. 24 plus 11 is 30, 35. 17 plus 4 is 21. So we take the maximum, which is 35. 35 plus 5 is 40. So the duration of the project from there is 40 weeks. That is what is known as forward pass. We want to now estimate the latest time. We subtract from right to left backwards and take the minimum. 40 minus 5 is 35. 35 minus 11 is 24. We are here and here. 35 minus 4 is 31. 24 minus 7 is 17. 24 minus 7 is 17. We write 17 here. Then we are faced by two parts here. 24 minus 14 is 10. And 17 minus 5 is 12. The other one was 24 here minus 14, which is 10. So the minimum is 10. Then we are here, 10 minus 0, because dummy activity does not take any duration. Its duration is 0. 10 minus 0, that is 10. Then 17 minus 11 is 6. So we want to identify the critical path. The critical path is the longest path in a network. It consumes more time and resources. It is the path which determines the total project duration. More so, along the critical path, earliest time must be equal to the latest time for any activity that falls along that path. Very many paths can be longest here, but it must satisfy the condition that earliest time must be equal to the latest time. This is 7 and 10, A cannot be along the critical path. So 6, 6, 17, 17. Then F. Somebody can be asking, why is it that this one is not along the critical path? And it is also, it shows that earliest time is equal to the latest time. No, it must be the longest path. So when you take this F, then you go to G, you'll find there is 7 plus 11, which is 18. But this one is only 4. So this is shorter as compared to that. So critical path must be the longest path, and along that path, earliest time must be equal to the latest time for any activity that falls along that path. So the critical path is represented by B E F G and I. Duration of this project is 40 weeks. So, viewers, I will do one more example next time when we'll have a lesson. Then after that, we'll move to how to crash a project. Thank you.